Second electronegativity of an element is chlorine. Third one bromine. The last one iodine. So order is chlorine, fluorine, chlorine, bromine, iodine. This is the order of the electronegativity of the elements. So here the order of the electronegativity of the elements is chlorine, fluorine, chlorine, bromine, iodine. This is the order of the electronegativity of the elements: fluorine, chlorine, bromine, iodine. So here the chemical effect of the chemical shift values influencing the electronegativity. So how to influencing the chemical shift by the electronegativity of the atoms? So here, for example, methyl fluoride. This chemical shift value or deshielding value, chemical shift is also nothing but deshielding. So here the chemical shift value is 4.28. Methyl chloride CH3Cl, this value is 3.0. So methyl bromide, this value is 2.84. So methyl iodide, this value is 2.16, like this. Here, if higher electronegativity of an element attached to the protons to the attached carbon, okay, so this chemical shift value is also increases. Why? Because the higher electronegativity of an element is attached to the methyl group. Hence, the chemical shift value increases. Hence, if the electronegativity is of an element is increases, the chemical shift value is also increases. Which electronegativity of an element attached to the methyl group or attached to the protons attached carbon. That is, if the distance of the protons from the electronegativity atom increases, the deshielding or chemical shift values also decreases. For example, methyl chloride CH3Cl. Next one, ethyl chloride CH3CH2Cl. So the distance of the protons from the electronegativity atom increases. This is decreases, this is increases, the deshielding effect decreases. Hence, what is this value? Yes, 3.0. What is this value? Yes, 1.5. Which value? Delta chemical shift values. These are chemical shift values or deshielding values. CH3Cl methyl chloride, this ethyl chloride. So increases the chain, carbon chain. Understand? The same electronegativity of an element attached to the chain, but this is the small, very shorter. It is a longer because of increasing the carbon atom. Hence, increasing the carbon atoms. Understand all of you? So increasing the distance of the protons from the electronegativity atom increases, the chemical shift values decreases. Hence, this value is 1.5. Delta value is 1.5. So next one, van der Waals deshielding. Next factor is van der Waals deshielding. In some cases, the electron cloud of a bulky group will tend to repel the electron cloud surrounding the proton. Surrounding the proton. Thus, such a proton will be deshielded and its delta values increases. In some cases, the electron cloud of a bulky group means one or more bonds between two carbons, bulky groups, each bond having two electrons. Hence, electron cloud means so one or more bonds between two carbons or two other elements. So, in some cases, the electron cloud of a bulky group will tend to repel the electron cloud surrounding the proton. Thus, such a proton will be deshielded and its delta value increases. For example, deshielded. For example, this electron cloud, bulky electron cloud or bulky electron group, that is, this is electron cloud. This repels the proton. Repels the proton. The proton will be deshielded. If the electron cloud deshielded, the electron cloud repels to the proton may be deshielded. The proton may be deshielded. Hence, the chemical shift value increases. The chemical shift value increases like this. The bulky group, bulky electron cloud repels the electron cloud surrounding the proton. Thus, such a proton will be deshielded and delta value increases. This is the van der Waals deshielding influencing the chemical shift. So next one, anisotropic effect. So this is also influencing the chemical shift values, chemical shift or deshielding effect. The delta values of unsaturated compounds can be influenced by the applied field. Due to the effect, delta values leads to downfield or upfield. These effects are described as anisotropic effect. So once again, the delta values of unsaturated compounds can be influenced by the applied field. Due to the effect, delta values leads to downfield or upfield. These effects are described as anisotropic effect. If the protons present in the shielding region, the delta values are lower than the expected. If the protons are in deshielding region, the delta values are higher than the expected. Once again, if the protons present in deshielding region, the delta values are lower than the expected. If the protons are in deshielding region, the delta values are higher than the expected. So, this is the factors influencing the chemical shift. So, next topic we are going to discuss tomorrow. Thank you.